All right, last time I said we were going to come back and do some more of these problems. We haven't actually done a problem yet, so I apologize for that if you were wondering what problem we had done. All we did was look at the rule last time and where it comes from. Now we're going to put it into practice. And it is not the most difficult thing in the world to do. You're going to find that after we do washers and shells, you're going to like discs the best. And I want to do all of the steps with these. I want to approximate the volume, right? Get a picture, approximate the volume, and then do the integration and make sure that our answer makes sense. So if we look at the square root of x from 0 to 4, if we graph these things here, we end up with 1, 2, 3, 4, 1, 2, 1. Okay. So we go from 0 to 0 up to 1, 1, up to 4, comma 2. Okay, we've looked at that shape before. You're going to see a lot of repetition in this chapter of very simple functions because I don't want to use real complicated ones. There will be some in the homework. You can struggle through them, but they're not worth you watching me do ugly integrations over and over again. The line x equals 4 is the vertical line there, and the line y equals 0 is the x-axis. So we're talking about the region that's captured by those three lines. Sometimes it'll be more than two curves, sometimes it'll be two, but you'll always be given enough curves to enclose a region and an axis to rotate about, which for our purposes will always be the x-axis. When we rotate this about the x-axis, we are going to get a three-dimensional shape. Looks roughly like that. I'm not sure what to call that. When we do this face-to-face, I insist that you all come up with names for these, and the name I usually expect for this is a bullet. It's sort of bullet-shaped, or like one of those helmets the Vikings wore without the horns. I'm told they actually didn't have horns on their helmets, which makes sense. Those would not have helped out in any way. And if we slice that into our cylindrical shells, each shell is going to look roughly like that. And our volume is going to be pi times the integral from a to b, right, the beginning to the end. That's going to be from our 0 to our 4. Our function squared, right, the radius of each one of these shells is the value of the function at that x value. And then the thickness of the shell is just dx. So there's our integral. This one's real simple, right, because it's the integral from 0 to 4 of just x dx. So we know that's going to be x squared over 2. Sorry, I lost my pi. Don't do that. X squared over 2 from 0 to 4. Plug in the 4, and we get 4 squared is 16 divided by 2 is 8. We get 8 pi. And I forgot to do something I always forget to do, and I always want people to remember to do, which is I want to come up with an estimate first. Suppose, I'm going to grab a colored marker here for this. Suppose we had put this shape into a cylindrical box. So one that fit right around there and right there, boom. Okay, little box for that bullet shape. What would the volume of that box be? Well, the radius is 2. The height is 4, so we know the volume is going to be pi times the radius squared, so 2 squared, times the height, which is 4, and that's going to be 16 pi. Does it make sense that that bullet occupies approximately half of that cylindrical box? Your intuition probably is not going to be great in 3 dimensions. Mine certainly isn't. But you're thinking about just ballparks. Is that in the ballpark of half of that box? I think so. So I'm happy with that answer. It does happen to be correct. Let's look at another one. That was movie magic right there, huh? Bet you can't figure out how I pulled that off. Y equals 4x minus x squared, that same function again that we've been looking at several times about the x-axis. I want to have a picture of it. I know it's an upside down parabola, and y equals 0 is the x-axis, so the region is bounded by the top curve and the bottom curve there. And we're going to rotate it about The x-axis, that's a terrible job there, should be symmetric. And it's going to look sort of like a top or a turnip or something like that, right? It's kind of round around the middle and sort of a little point there and a little point there. You want to understand what the shape looks like. I can't really think of much for that aside from turnip. I'm trying to make it look three-dimensional. I'm not doing a very good job this time. If we were to put a box around that, right, put a cylindrical... My dog hears ghosts all the time. So there's a cylindrical box. Our height is 4. Our radius here is also 4. So the volume of that box is going to be pi times the radius squared, so times 4 squared, times the height, which is 64 pi. And I'm going to go ahead and guess that the volume of the box, or the proportion of the box that's occupied by that shape, is probably a little bit more than half. So I'm going to guess that our volume ends up being 32 pi, maybe a little bit more. Well, let's set this up. The volume is going to be pi times the integral from 0 to 4 of the function 4x minus x squared dx, but the function itself squared, right? The function squared dx. Well, that's going to be pi times integral 0 to 4, 16x squared minus 8x cubed plus x to the 4th dx. So that's going to be what? 16x cubed over 3 minus 2x to the 4th plus x to the 5th over 5 from 0 to 4. And I can finish this. I don't know if this is going to be worth watching. When we plug a 4 in here, 4 cubed is 64 times 16. Well, that's 4 squared. That's 4 to the 5th power. What the hell's 4 to the 5th power? I'm cheating. 16 times 4 to the 3rd is 1024 over 3 minus 4 to the 4th power is 256 times 2 is 512. 4 to the 5th power is, I don't know, 4 to the 5th is 1024 again. So that, whatever that is, I'm cheating here. 1024 divided by 3 minus 512 plus 1024 divided by 5. 34.1333. If I convert that to fraction, 512 over 15 times pi. Good exercise if you want to do that. I don't at the moment, but the decimal approximation for that is 34. I said it might be a little bit more than half of that, so I am happy with that answer despite the fact it's ugly. You're going to see that a lot in this topic. You're going to start out with something that looks pretty nice, and you're just going to get some ugly fractions. Feel free to use the calculator for them. The most important part of this is right here, the setup. The rest of it you can do in the calculator. Next time.